All right, let's get started. All right, so to begin with, I like to do a little format cleanup here. Default with 8, and we'll turn this into a table. Don't need this Portuguese column. With the equipment, we have similar data, same structure, same columns. So I'm just going to bring this over here so we don't have two different tables to deal with. Call this table T, and then icon, name. We don't need this description column. And now we have to separate the effects. So they're given in a delimited format. So create attack, defense, dexterity, technique, and magic columns. And then handle each one here in a let. So let the label, we're going to say this is text before split. Oops, not my custom split. Text split. Text split, this one. And then text before the colon. For the value, we want the text after. After this space. Now when we do our lookup, we're going to look up the column header, but instead of referencing the column name directly, we're going to use a cell reference. That way it can be dynamic. So we're going to look that up in the T headers. Oh, I'm sorry. No, we're going to look this up in value labels, return value. The benefit of doing that, anchoring there with the cell reference, is that we can make it dynamic, copy and paste over, which is pretty nice. All right, so we're going to do something similar for the requirements. Each item has a minimum dexterity, a minimum technique, and a minimum magic. So we'll use that same formula, but tweak it a little bit. So reference the right columns here. The value is found after a greater than or equal sign instead of a space. And our column headers have the label min concatenated there. So I'll change that. And yeah, it should be good. So let's get started now with our actual questions. Starts in a very famous way, just to do a simple lookup of the name. I want to see my score as we go. Okay, so here we're going to sum the weights of all of these. So T icon, T weight, give a 0 for error handling for those blank cells. On this one, we're going to filter the highest attack item, the highest defense item, but there's a trick, which is tie break. So to handle the tie break right up front, we're going to sort our initial values by the weight. That's the tie break value. T icon, T weight. And by doing this, we can just filter our answers at the end and take the first value. So that's helpful. So we say names is going to be XLOOKUP items, T icon, T name, and then we can copy and paste this 2 times to get the attack and the defense. Okay, and now that we have that, we'll say I want to take filter. We want the names where attack equals the max attack, and then we'll take the first column of that, concatenated by ampersand spaces here. And then we'll do it again. Take filter, names. We want the defense this time, where defense equals max defense. Take the first one, and we're done. All right, here we want the strength of each item. We have some starting values and some modifiers. So we'll say D, T, M, attack, and defense. What we want to do is take our starting value, which can't go below 0. The starting value plus XLOOKUP. No, I'm sorry. The sum of all these XLOOKUPs. So we're going to look these up. T icon. And then we want the return column to be dynamic. So we will look up this value up here in T headers and return the whole table. Like so. Now, as we copy and paste, it should stay with us. When we get to attack value, it errors out because there is no given initial value for attack. So we'll just fix that part. Now with all of our values calculated, we can do the final formula, which is d squared plus t divided by 3 times z to the m plus 2 times attack plus defense squared. And that should be 1696. All right. So equals those. Good. Okay, for this level, we're starting at an arrow and we're moving through that direction until we hit a different direction arrow. Okay, before we start, we have to deal with this map. So let's do some setup here. We're going to highlight the map and give it a named range of map, and then come out here and use our table lambda, copy and paste values, and turn this into an actual table called M. With that, we'll say equals array. I want only these arrows, so I'm making a named range with called A, and then in our table, I'm going to go through and say for each value, is this an arrow? So is number x match this with A, trues and falses all the way down, and we're good. So we can start now. We'll say let start be this value. Direction is going to be XLOOKUP of the start, looking into that new table that we just made. Okay, so that's our starting direction. Now for the path, it's a variable amount. It could go 10 spots, it could go 30, we don't really know. So I'm going to make a recursive function to get the path. So the path is going to be lambda me, self-referential there, lambda address, and then an optional parameter for the items that we pick up along the way, and let. Okay, so first step will be calculating the next address, which I can use a custom lambda that I have that already handles it. So you feed it an address and a direction, and it gives you the next address in that direction. So the value is XLOOKUP next m address m value with the error handler. Okay, so we've got that. I'd like to know if it's an arrow or not. Next, I'd like to say, do we have an item to grab? So we're going to grab this item if it's not an arrow and the value is not 0. With any recursion, we need a stopping condition. So we'll stop if, what's our stop? We're going to stop if it is an arrow, but the arrow is not equal to direction. Okay, so now we execute our recursion. So we'll say if stop, return items. Otherwise, recursively call myself, passing the new address, which is next. And items will be if grab, then we want to concatenate items with the value of that round. Otherwise, return items. All right, now we can execute our recursion with this recursion helper lambda that I wrote, which is just syntactic sugar. Recurse path, we're going to give it the start. There we go. Okay, next level. This is similar to the last one, so we'll copy and paste this, and we'll just move our starting over. Now, the difference is that A, we're going to be not just going to the first arrow that it defines. We're going to continue that in a different direction up until we find this little symbol here. So I need to isolate that symbol and give it a named range, which we'll call N. The second change is that we can't just pick up all the items along the path. We have to check dexterity and capacity requirements as well. So we'll handle just the first is the directions. We'll ignore dexterity and capacity for a moment. Just handle the pathing. So for the pathing, we're going to stop if value equals end. The other difference is that now the direction can change, so we can't rely on a static direction. We have to pass the new direction each time. So direction is a parameter now, and we'll pass the new direction at the end. At the beginning, we'll pass the original direction, which we'll name O direction, original direction. And after the arrow here, we'll say new direction is going to be if arrow, then value, otherwise old direction. And that should give us the whole path. So it'll pick up every item so far. So 1, 2, 3, 4, 5, not 4. So we're picking up everything as it stands. Now we need to deal with the dexterity and capacity requirements. So we'll add in dex and cap. And then over here, we'll pass new dex, new cap. At the beginning, we'll pass our starting values. And then right about here, we'll define our new dex to be if grab, then dex plus x lookup value in what? T icon T dex. Otherwise, if not grab, then just give us the old dexterity value. The same logic will hold for capacity, with the exception that instead of adding to the capacity, we'll be subtracting the weight of each item that we pick up. It should be weight. Okay. So at this point, we just have to change the condition of the grab to include the minimum dexterity requirements. So we'll say dex has to be greater than or equal to x lookup value T icon T minimum dex. And then we can copy and paste this logic into the capacity area. Cap has to be greater than or equal to the weight. Cap has to be, okay, this is weight in space. Okay. All right, good. Next, Laennder. We have a formula here. We need attack, defense, same things before. DTM. This time we need energy as well. We'll throw in an optional parameter of like which one we want to return, defense or attack. So it's going to be if return defense, then give defense, otherwise attack, times 4 times D plus 2 times M plus T to the power of 1 plus E over 10. And then save that lambda. We'll call it attack. Okay. Now, this is a complicated level, so we're going to create a data table sheet and start off with our starting values using text splits. We've seen this before. That's the ones after the space, and then turn it into a value as well. So this is DTM, initial starting values. Here we'll want help. Here we're going to text split with an array of delimiters carefully entered here. So we have left bracket, right bracket, space, and pipe. And so we can wrap calls to get a row for level 1, level 2, player 1, player 2. And I'm going to isolate these. So choose rows 1, because it's just player 1 to deal with right now. That's all I want. So class is going to be the lookup of these to class. We're going to be lookup, T icon. Returning T class. Okay, and then we want to know if we're going to grab these items or not. So it's going to be starting value is greater than or equal to X lookup of the minimum dexterity. Okay, so but that's only one condition. We have 3 to deal with. So we'll modify G6 and G7, and then change this to min technique and min magic. So now we have 1s and 0s that tell us, are we going to use this weapon or item? Okay, now base attack. The X lookup of the item's attack rating. Okay, but we only want to look at ones that we grab, so multiply by that. And we only want items that are actually weapons, because there are attack modifiers. There are attack modifiers that are also there when it's not a weapon. So we have to handle that separately. So we'll handle that here, and so we'll take this same formula. So instead of saying it is a weapon, it's not a weapon. These are the item-based modifiers for attack. And we'll just start from 0 and give a running total. And then from here we can add base attack. So this is our attack level for each round. The base attack, if it's positive, it means we actually attack in that round. Okay, so for defense, we need the same thing. We need the same thing for defense, so we're going to change this right here to be defense, and then change this. Instead of looking at weapons, we want to look at armor. And then same thing here, copy and paste. We're going to move this reference to base defense. We're going to change this to defense, and we're going to look at only armor. Okay, let's reorder these a bit. Now we have attack and defense. We also need dexterity, technique, magic, energy, and then we can calculate our final attack value and defense value. So D is going to be equals X lookup T icon TD multiplied by only the ones that we grab, and this is going to be a cumulative effect as well. So we'll scan from 0, and at the end we'll add our starting value. So we have 4 decks all the way around. There are no modifiers for this particular example. That's okay. Next we have technique, and change this to T. Next we have magic, change this to M. Okay, for attack, I couldn't find an elegant way to make this dynamic. So we're starting with 0s all across here, and we're going to say if the last round was an attack, reset our energy level, otherwise look at the last energy level, plus we need to pause for a second and create a named range for this energy symbol. So we can refer to that here now. If this value equals energy, then 1 or else 0. Okay, so we've got energy modeled out. Now we can use our lambda that we created at the beginning to say attack, defense, D, T, M, energy, and attack. We need to make this an integer, and we can do the same thing for defense, only we have to put in that optional parameter to return defense. Okay, now I think I did something wrong because look, if you see like this column right here, it shouldn't be attacking. It's an item based, not a weapon based. So I think on our attack rating, I need to add like if base attack is greater than 0, then do this. Otherwise, the whole thing should be 0. That looks a lot better. So we'll do the same thing for defense. So if base defense is greater than 0, do this. Otherwise, 0. Okay, those look good. And now we have to handle player 2. So earlier we had just isolated level player 1 by using the choose rows here. We're going to do the same thing, but put in player 2 here. All right, we need the starting values, which can be found over here, and then just copy the whole thing. So that's our player 2 values. Next, we get our final answer of the net. So we'll say if that's positive, then give me the max of 0, or attack minus defense. We do that because we don't want the defense to overwhelm the attack. You don't lose points in that situation. So minus if the defender is player 2 is attacking the villain, then we'll say max 0. Villain attack minus hero defense, and that's our net. So now we say absolute value of the sum of these final numbers. And we're all good except for level 115. So we go to 115. See, okay, remember earlier we can't have a negative attribute here, so we have to make sure that on a bi-column basis that just see that we never go past 0. And now it's right. Okay, so we go to bonuses now. How many items can be used with dexterity level 3 adventures? So we'll say equals sum. What is this going to be? T min dexterity is less than or equal to 3. But we only want items, not weapons and armor. So we'll say is an a X match. And then we'll give T class with an array of weapon or armor. Like that. Okay. That gives the right answer. Okay. From each equipment collection, what is the total weight serving only the heaviest equipment? Okay, so total weight will be sum of the second column of our group by. And we're going to group by T type, returning T weight. Okay. We want the maximum value. And then we're going to filter on this time we want only weapons and armor. So choose calls 2 and then sum. Alright. So using level 4, we have 7, 2, and 1 as starting values. Okay, so level 4, 7, 2, 7, 2, and 1. The attack is going to be the highest attack item, so it's going to be equals max filter T attack where what? Where these minimum conditions are met. So we'll say this is greater than or equal to T min D. That's one condition, and we'll just copy and paste that a couple more times. So this is going to refer to W, this refers to X, this refers to T, and this refers to M. So that should be our max attack. Copy and paste, changes to defense. That's our defense, and then we can use the same formula that we had before for the final answer. Good. All right, based on logic from level 6, we explore every possible path, and then how many cells are walkable. Okay, so level 6, how many cells are walkable? So here we are in level 6. We'll take our formula here. We can strip a lot of this. Okay, we only care about the pathing this time. So we don't care about capacity or grabbing items. So we'll take out these variables here. So no more capacity, no more jacks, no more items. That should, okay. What are we hoping to get by that? So instead of giving items, we want to return the pathing. So I'm going to text join address with the next address, and then text join address. Let's see, text join this ADD next. Did something wrong here. 80 recurse lambda. Okay, so for a given string, for a given arrow, this returns the whole path of the addresses, including the beginning and ending one. Okay, so now we turn this into a lambda, and we'll filter on all the starting arrows. So we're going to map all the starting arrows. So map of filter is going to be what? Filter M address. Filter M address where it's an arrow. Lambda start let. We'll get rid of this start. We'll close the parentheses at the end. Now that gives a whole list of paths, and we'll just concatenate them all with the text join. That gets one single long path. Let's split that up. And then unique, and then count them. So take this whole formula, paste it in over here, and cross our fingers. Yay. Okay, following logic 6, there's one item on the map that cannot be captured even if you walk through every available path. So we have a lot of this solved already. Instead of using the count, we'll just take that unique and search for every value on the map. So we're going to say, what? Filter M value. Filter M value on is NA X match address, M address. Close this up. That gives the value here. Now look that up and get the name. Magic popcorn. And 12:50, 29 minutes. Woo! Yes. Thanks for watching. I'm Excel Gladiator, and my goal in creating this video is to help people level up their Excel skills, as well as grow the world of Excel esports. If you want to help me do that, please like and subscribe, drop a comment, or check out one of these other videos.